Number 7. Now we're going to get to a little trickier things. We're talking about an inverse function. An inverse function is when you take and switch the x and the y around, and then if it was an equation, solve it for y. If it's just ordered pairs, I'm just going to switch my ordered pairs around. So functional notation for an inverse is to say that it's to the negative 1 power. This means the inverse of g. G is our original function. So all we're going to do is take each of those ordered pairs and switch the x and the y's around. So our new function, instead of being -9, -2, is going to be -2, -9. Instead of being -2, 7, it's going to be 7, -2. Instead of being 2, -4, I'm going to write that down here, is -4, 2. And the last one, instead of being 6, 4, or 4, 6, is going to be 6, 4. So all I did is switch those around so that the x became the y and the y became the x. So, this is asking me, in my inverse function, find the point that has the x value of -2 and give the corresponding y value. What would be the corresponding y value for the point that has an x of -2?
Oh,
You're looking at these points over here, right?
yeah.
Which one of those points has an x value of -2?
The 4? Oh, -4?
No.
Oh, what then?
Which points have -2's in them?
Oh, that -2 minus 9
Ah,
and 7?
this is my x, this is my y, right?
Yeah.
This is my x and this is my y. So which one of those points has an x value of -2? The first one, right?
Oh, is that what I'm looking for?
So I'm looking for this point, and I want to give the corresponding y value of that point. The y value of that point is -9.
Okay. So I'm looking for what's in front.
Yep. Because the x is always in front when we give our ordered pairs.
So that x and y is going to be
Now, on the next part,
next.
we have this. However, we want to write it in regular notation instead of functional notation. So instead of writing h of x equals 4x minus 3, I'm going to write it as y equals 4x minus 3. That would be how we would have to write it to draw the graph. Inverse functions are when you switch the x and the y around. So we're going to do the inverse. The inverse means I'm going to do x equals 4y minus 3. Now I have to rearrange this and solve it for y. So if I want to get the y by itself, I would want to move the -3 over here with the x, right? So this is going to be x plus 3 equals 4y. I still need to get rid of the 4, so now I'm going to divide by 4. They're going to let you just use one big fraction instead of doing two separate fractions, so we'll just leave it like that. So our answer is that x plus 3 over 4.
Oh,
Okay? Now what this one is, remember we did the composition of functions the other day. We had to go backwards. We put the 1 into the inverse function, and then once we got our answer, we put it into the h function. So we're going to start here and put the 1 into here. So h of -1 is going to be x plus 3 over 4, but we're going to put a 1 in for that x. So 1 plus 3 is 4. We get 4 over 4, which happens to be 1, right? That doesn't happen very often. You get the same number you started with, just it happened on this one. Now once we got that answer, now we're going to do it into the h function. So now we're going to do h of 1. the h function is our original function. So we're going to do 4x minus 3, which is our original function, but in for the x, we're going to put 1 again, because we got a 1 for our answer. And so when we solve that, 4 times 1 is 4, 4 minus 3, hey, we got 1 again. After all that work, we got 1s, 1s, and 1s all the way through on that one. So it's telling us, put 1 into the inverse answer, and then once you get that answer, put that answer into the h. We just happen to get 1s, 1s, and 1s. The next one probably won't happen that way. We'll find out. So, number 8. First of all, it wants us to do our inverse of g. So g to the negative 1 is going to be what set of ordered pairs?
It's going to be 2.
Negative 2.
Negative 4.
Negative 4. Our next ordered pair would be?
1. Negative 1.
Negative 1. My next ordered pair would be?
6 and 1.
And my last ordered pair?
Negative 4 and 6.
Okay. So the question says, in my inverse function, which point has an x value of 6?
Negative 2 and 4.
That has an x value of 6?
And then,
Right?
Okay, wait, no.
It tells me I have to use 6 on this one.
6 plus 1 is 7.
You're not doing any adding. You're just looking at your points.
Okay, well
and
then it'd be 6 minus 1.
6.
I mean, comma 1.
So, there's my point with my x value of 6. The corresponding point that goes with that is the 1. So I'm going to put the 1 in there for my answer. Okay, now we're going to do that inverse function thing. This is h of x equals 2x plus 13, but we're going to rewrite it with a y instead. So y is equal to 2x plus 13. We then need to do the inverse. So we're going to switch around our x and our y. So how should we rewrite that?
It's going to be x equals 2y plus 3.
Plus 13.
Oh, 13, I forgot my 1.
And then we have to go through and solve that for y. So if we're going to solve that for y, what should I do next?
You can do x plus 13.
When I move my 13 over, it's going to be
Negative.
x minus 13.
X minus 13 over 2.
So over 2. Yep, it is a 2. So x minus 13 over 2. Okay, now on this one, they switched it around a little bit. I'm going to put my negative 5 into which function first?
Okay, h.
Into the h one. So h is equal to 2x plus 13, right? It says there up on the top. If I put my negative 5 in for the x, what am I going to get?
Minus 3.
So I'm going to get,
Minus 3.
not minus 3,
3.
3. Because this is going to be negative 10 plus 13, which is 3, right?
Yeah.
Okay? So now I'm going to take that 3, put it into the h of minus 1 function. That's our answer that we got here. So x minus 13 over 2, we said that was 3, so we're going to put that in there for the x. So 3 minus 13 would be
10.
negative
negative
10 over 2, which is
negative 5.
negative 5. So negative 5 is our answer. All right. Let's try number 9 then. Number 9, first going to do the inverse of our g function. So writing down our ordered pairs, they are going to be what?
It's going to be negative 2 minus 4, 1, negative 1, 6, and 1, and negative 4 and 6.
So, our question, what do they want us to find in our question?
They want us to find,
There's got to be a typo in there. I think that's supposed to be a negative 2. We're going to make it a negative 2, otherwise it won't work. There we go. Make that a negative 2 instead of a 2. Either she typed a negative on the top or there's a negative in there somewhere. She shouldn't have had one.
our function negative 2, so would that be the minus 2 and 4?
And so what is the answer that we're going to put in for that? What would we type in?
Negative 2. Oh, you got a negative 4.
If this is negative 2, this is going to be
Negative 4.
negative 4. Exactly. So I find that point with the x value of negative 2 and I write down the negative 4 that goes with it. All right, so on the next one, or the next part of that, I've got to do the inverse of my h function. I'm going to rewrite it with y equals 9x minus 4 over 3. But then I've got to do the inverse. So I've got to switch my x and my y around. So what should my new equation say?
The new equation should say x equals 9y, 9y minus 4,
Over
3.
3. So this one's a little bit trickier than the previous ones we did because we have that fraction, right? How do we get rid of the fraction?
We
Whenever
are going to, the 3 is going to go to 3 once, 3 is going to go to 3 9. I mean,
Nope,
right?
nope.
Nope.
I can only do that if all of them are divisible by 3. They're not.
Oh,
But if I have a fraction in my equation and I want to get the fraction out of there, what step do I do?
I'm going to minus, you're going to multiply.
Multiply by the 3, exactly. Times by the 3, so we can cancel the fraction. So 3x is going to equal 9y minus 4. Now it looks a little closer to what we did on the previous 2 problems. So I want to get the y by itself. The next thing would be
And the next one's going to be, you're going to move, and I can't see a darn thing. So.
I want the y by itself, so I need to move my 4.
Move your 4.
So what am I going to do with my 4?
You're going to take it to the left,
And make it
negative, positive 4.
positive 4. So 3x plus 4 equals 9y. And if we have 3x plus 4 equals 9y, we still need to get rid of the 9, so we're going to divide. So our inverse function is 3x plus 4 over 9. All right, so last part of that problem is finding h of negative 1 of 5. We're going to put the 5 into which one of our functions first?
H negative 1.
The h negative 1. h negative 1 function says 3x plus 4 over 9, and it's telling us to put 5 in the x spot. So 3 times 5
It's 15,
plus 4,
19.
19. 19 over 9. Can't do much to simplify that. We just get to work with a pretty fraction.
Okay.
Now, we're going to take this answer and put it into the h function. So the h function says we're going to do 9x minus 4 over 3, right? But now we've got to put that 19 ninths in for that x spot. So 9 times 19 ninths minus 4 over 3. And what happens when you take 9 times 19 ninths? Right, when you do 9 times 19 ninths, what will happen with that?
9 times 19 ninths?
Uh-huh.
I think it says 19.
It did say 19 because the 9s cancel each other out.
Oh,
So 19 minus 4 then. 19 minus 4 would be
negative 15.
15, and 15 over 3 would be
5.
5. Now, look back at all of your 3 previous problems. At this third part, notice, we started with 5, we ended with 5, right? The second one, we started with negative 5, we ended with
Yeah.
negative 5. The first one, we started with 1, we ended with 1. If you did this all correctly, an inverse function undoes whatever the previous function did. So that should always happen. Whatever this number is, your final answer should be this one. The one in the middle might be something weird, but the final answer always should match up with your beginning answer.
Okay.
That way you know you did the whole problem right.